Hello, this is Mark Tucker. Welcome to my video series, Jovo for Explained. Today, Lesson 1, Introduction to Jovo. So why am I doing a video series on Jovo? Well, partly because I've done a lot of application development work using Jovo over the last number of years, since 2017. I've created Alexa Skills, Google Actions for Google Assistant, web chat, web voice assistants, and just overall really enjoy the Jovo framework. I think there's a lot that it has to offer and continue to offer developers who are looking to do some sort of a chat bot or voice assistant experience. I was able to host Jovo in a number of different ways, including AWS Lambda or in a Docker container in Kubernetes. Not only have I been a developer that has used Jovo, but I've also written over a dozen plugins to extend functionality, things that I needed for projects at work or for side projects that I was doing for fun. And plugins are a great way to be able to create that functionality and share it with others. So today we're going to go over the 4 P's of Jovo. First, we're going to talk about what's the purpose of Jovo. Then we're going to cover the topics of platforms, pipelines, and plugins and how they fit together. Those 3 things are the primary functionality of the Jovo platform, and once you know that, then the Jovo framework is just really opens up to you. So let's start with this example from scratch. What would we do if we didn't have Jovo as a server-side framework to use? Let's say that we have a web chat client and we want to be able to build the logic of the chat, but we want to build that into a server API, so a REST API. So we go ahead and create some sort of an endpoint using a library like Express.js or Fastify. Let's say there's a /bot endpoint. Accepts a HTTP post body, that JSON request. Let's say it has a number of different pieces of information. Our server is going to be stateless. That means that if we have information that's about a user, we're going to need that information passed in. Let's assume that our web client allows you to log in and the chatbot itself requires you to log in. And so there's some sort of a user ID, username that is associated with the user that is using it. And we want to be able to differentiate that user's experience from somebody else's. Maybe we also want to pass information about the device that the user is using. And what type of capabilities. Does it have a display? Does it play audio files? What functionality does the device have? And we want to pass some of that information along. When you interact with a bot service, in this case, then that interaction is going to be within a session. So as you do a request, it goes to the server. The answer is formed, returned back as a response. And one of those is a conversation turn. And you put multiple conversation turns together in a session. Maybe you come back the next day, you interact with the bot again. That's a different session. And maybe you want to be able to track that ID uniquely for that session. And then the request itself. Each turn of the conversation is a separate request. If you were to log information about and include the request ID, you could be able to put those together. And let's say that since it's a chatbot, the text that the user is typing in the web app is then passed from the client to the server. So we don't necessarily want to build any code into this server. Its main job is to expose an endpoint and be able to accept the JSON that we pass. So let's go ahead and create an app object. This is a good point to talk about what types of apps can we build. We can build applications that are command driven, something like turn on the lights, open the garage door, things that are given specific commands. It also could be a specific command like what time is it, and you can get some sort of a response back. You can also write an app that is question and answer. So the user asks a question, the bot responds with an answer, and that's a little bit different flavor of an experience. Conversational is more multiple turns together. So maybe this is, having a conversation with the bot, or the bot is asking you questions to gather information for maybe making a airplane reservation, and it needs the city that you're leaving from, your destination, what dates you're traveling, that type of information. And it might take a couple of turns of the conversation to gather all that information before it does something. There's also the ability to create type of bots or other experiences that use an LLM. It could be using a large language model to answer questions about, frequently asked questions from your website, or it could be having a conversation with a fictional character that takes on a certain persona. There's lots of different things that you can do. So the app is going to take in our request, and it's going to do something and then build up a response. And maybe we want to pass the ID of each of those different user, device, session, and request back. If we wanted to somehow correlate that with our client application, and then the response that gets built up includes text of what the bot's going to respond, and that will be then a separate bubble in our chat application. So this is a way that we could have started off if we were just building this from scratch. But let's say that we want a little bit more functionality. So we know that the web chat is going to pass some JSON information to the application, and so that request object that gets passed is very specific to the web chat. And if the user typed in certain text, let's say this is a joke bot, and the user types in, "Tell me a joke," or they could type in something different like "joke please," or "I want jokes about animals," or "I want jokes about airplanes." So that text that's coming in, you could try to handle that text by yourself, but you'd have to then do things like regular expressions or search for specific hard-coded strings. And that's where a natural language understanding or an NLU model would come into play. So you would train an NLU model with various different phrases, tech phrases, or utterances, and say that these all map to the joke intent. So it doesn't necessarily matter what exactly the user types. In the end, that gets resolved to a joke intent, and then in your handler you can say, if the intent is joke intent, then you can do something. And that something could be calling another API. It could be maybe we have a joke database, or we have a joke service that we call to get our information. And then the handler is where you would put your code that's specific to this bot application to then form up the response and then send that response back to the client. If our bot was able to also do something like answer "what time is it," then that could go in, that request could go through. The request would be a little bit different. It's got different text like what time it is, but the NLU model could say, "Oh, this is a time intent." And then your handler could have some conditional logic in it. Says if the intent is time intent, then maybe it just uses the time zone of the user and what current time it is to format what the response is. So that's breaking up some of the functionality that we would see in lots of different applications. There's a request, there's a response, some sort of NLU, some sort of handler. Let's investigate this just a little bit further. So what if instead of just a web chat client, maybe we have a mobile voice client as well? Maybe we want our functionality to be used in Alexa or with a custom SMS. Now, each of those JSON requests and responses would be different based on which client that we have. So together, we can think of that request and response and any logic that it needs to figure out that, hey, this request is for web chat or this request type is for Alexa. If we were able to put that together, we could combine that into, let's refer to that as a platform. So we can use the same single bot server endpoint, and we can send different structures or different schema of JSON to that server, and the application would be able to say, identify the request, and that request that we're talking about up here is a platform-specific request. And but if there was a way that we could then know where to look in that request and say, this is the text that the user typed, or this is the audio that we're sending along with the voice assistant, or this is the intent that Alexa passes you. If we were able to put that into a generic, kind of a more generic object called input, then what we have is we have the request being platform specific and the input being more generalized. Then we could take a look at that input and say, do we need to pass it through automatic speech recognition? In the case of web chat, we probably don't. In the case of mobile voice, we probably do. And then at that point, we could say, oh, we know what the text was, either because we have a transcript or because the text was passed in, and we could run that through NLU and figure out which intent it was. Or in the case of Alexa, actually, Alexa goes through a different Alexa service, which handles the ASR and NLU by itself, but by the time it gets here to the input, we actually already know what the intent is, so we can skip the ASR and skip the NLU and go right to the router. So now instead of having our code have that condition and the router to determine what code's going to handle next, then we're able to separate that into its own code, and it can look at where you are in the conversation and what the current intent is, and know what the next code handler, what's the next component that's going to handle the code. So a lot of this stuff could be reusable, and actually could be calling some third-party provider for ASR or third-party provider for NLU. And this is like a consistent way of routing. So really the place that you would be putting code would be mostly these component classes for handlers. And this handler would be called based on the router, and then it would help build up an output. It could call an API. It could do whatever it needed to build up the output. And that output would be more generalized. And then there would need to be some sort of a code that would convert that more generalized output into the response that's specific based on the request that came in. So if it was an Alexa request that came in, then the output would be formatted for Alexa and returned back to the client to be displayed or spoken on an Echo device. So now we start to see that we can start, there's a certain number of steps that are in common regardless of the type of application, regardless of what the client is. And so if we were able to build some sort of a framework that took that into account, then we could start doing things consistently across multiple projects. So let's take a look at Jovo itself. What is the purpose of Jovo? What can I build with it? So Jovo, the Jovo framework is written in TypeScript. It's a server-side framework that can be hosted various different ways, and you can, out of the box, create an Alexa skill, Facebook Messenger bot, Instagram bot, or you can write some sort of a custom chat bot or voice assistant or SMS assistant. And because it runs on the server, then it has some advantages. One is that it can support multiple different types of clients. It could support a web client, a mobile client, desktop, custom hardware that you're making yourself with a Raspberry Pi or something, or some proprietary hardware like an Echo device for Amazon. It doesn't really matter what the client is, as long as we've talk about what the communication is between the client and the server and what format the JSON is in. And so that allows us a lot of flexibility. It allows us to encapsulate the functionality of the server and keep that away someplace separate. It allows us to, we could keep the client hardware small if it was something that we were building ourselves, because a lot of the functionality would be on the server. We could update the server separate from the client, and there's just lots of advantages to having it be on the server side. So if you look at the Marketplace tab on the Jovo website, you can see a section called Platforms. And these are, out of the box, the different platforms that are supported. Alexa, Facebook, Messenger, Instagram. This web platform is for writing things like chatbots and voice assistants that are hosted on web. And this web platform is actually a specialization is derived from this core platform. So if one of these platforms doesn't work for what you're building, then you can either create your own platform based off of the core platform, or you can create your own platform from scratch and with these files. So for example, this request would indicate how what information is in a request, and that's specific to your platform. Same thing with the response. How does the user and the device look to that, to your system? For example, where in the request could I find information about the user? Where in the request could I find information about the device? This platform helps you identify, based on the structure of the JSON, that this is in this case, a MyBot platform, and so the request it should be in this format. The response should be in this format. This output template converter is the thing that defines or converts the general output into the platform-specific response, and that's all possible with Jovo. Before we talk about the next concept, which is pipeline, Jovo has this concept of the writer lifecycle. And if we think about things at a top level, in this case, this is a voice assistant. The user is asking, are you open tomorrow? So what the user said needs to be converted into a request, sent off to interpretation. That would be things like the automatic speech recognition or natural language understanding. This dialogue and logic would be looking at the current day, maybe reading a database for your store hours for the next day, and figuring out if you're open or not and what time. Helps build up the response, and then the response comes back, yes, we are open at 9 a.m. So this pattern is followed by lots of different things. It could be a voice assistant, it could be a chatbot, but it's the same type of thing. You've got some sort of request, some sort of a processing of that request to understand what it means or what's being asked, the actual logic that happens, which could be an API call or calculations, building up the response, and then the actual delivery of the response. So if we went back to our from scratch example, we've talked about the platform and where a server can handle multiple different platforms. And this request is a platform-specific request, and this response is a platform-specific response. But if we look more at this section here, then this kind of repeating steps, if the things that happen on each request that comes in, then it goes through and follows each of these different steps, builds up the response, returns that back to the client. Maybe the user then says something in response, it comes back as part of the same session, and it goes through these same steps again. And those steps are considered the pipeline, or what I call the pipeline. And if you notice that the pipeline is sectioned off into different sections that follow that writer life cycle, the request, interpretation, dialogue, logic, and the response. Now, what's also you see on the far right side of this is what Jovo calls middlewares. And middlewares are steps in the pipeline that are followed in a specific order. If you're used to things like middleware for Express.js or others, then it's kind of more free-formed as far as the order that middlewares are called are based on the order that the developer adds them. And in Jovo, there's a very specific process. Since a lot of these applications follow the same structure, then you're always going to start with the request.start, then the actual request, and then the request.end. You notice each of these sections have a start and an end, and then there's different steps in the middle based on what type of kind of what section it is or what grouping it is in. So instead of like having the app call the request and then call the input, then call the ASR and then call the NLU, this pipeline creates a Jovo object. So the app creates a Jovo object, sets on that as a property the original request coming in, and then as it's going through each of these different steps in the pipeline, then additional information could be added to that Jovo object. And so that Jovo object passes through each of the different steps in the pipeline. So any platform, any component handler code, any code that's specific to plugins, which we'll talk about, will have that Jovo object where it can add information to it, read information from it, and help process that step through. So what is a plugin? If you look on the Marketplace tab on the Jovo website, you'll see a lot of different plugins in different sections. But platforms themselves are plugins. And this helps reinforce the idea that a lot of the integrations that are part of Jovo are done through plugins. And plugins are first class or primary class citizens in the framework. So you can specify databases that will save off user information and retrieve it, keep information about the user across sessions of this bot. This could be third-party ASR or third-party NLU providers. Could be wrapped up in plugins. It's various different business logic, content management systems, output, text-to-speech, logging, and analytics are all different integration types that you can do with plugins, and you'll see examples of those on that Marketplace tab. So what are some things that you need to know about plugins? Every Jovo application has to have at least one plugin, and that plugin has to be a platform, because otherwise you don't know what type of application you're building or what client you're communicating with. So you need to have at least one platform plugin enabled, but you can have multiple. You can support multiple platforms at the same time, have it be cross-platform. Plugins can be either global or linked to a specific platform. So you could have, platform A uses NLU provider A and platform B uses NLU provider B, if that's the way that you want to structure your application. Plugins can listen for one or more middleware steps. And as the pipeline is being processed middleware step by step, then any plugins that are associated are listening for a specific middleware step. When that happens, then the code that has to deal with that plugin is executed for that step. Now, each middleware step is listed also supports a before and an after. So like the very first middleware step is request.start. So there is actually a before.request.start, a request.start, and then an after.request.start. And so those are all places where you can plug in listeners to do some certain logic. Now, a plugin can also add custom properties or functions to the Jovo object itself. So you can extend Jovo to take advantage of other functionality by associating that with the Jovo object. So that's another thing that a plugin can do. You can write your own. I encourage you to do that. It's not too hard to get started. You can look at some other plugins as examples. There are various lifecycle hooks. You don't necessarily really need to know what they all are, but a plugin can be installed, it can be initialized, mounted, and then dismounted. So mounting is basically where you're going to register which of the middleware steps you're going to listen for. Plugins are a good way to integrate with other services or additional functionality. It allows you to have reuse, and it's just a good way to package things up. There's a concept called hooks, which are lightweight plugins. Plugins incorporate a lot more functionality and kind of a little bit more formalized of a concept, whereas a hook allows you to just associate a function with a specific middleware step. And so sometimes it's easier just to create it as a hook, but if it's something that you want to reuse and share, then you would do a plugin. This is an example table. I just want to show the relationship between middlewares and plugins. So off to the left here, we see all the different middleware steps, starting with request.start all the way to response.end. So here is a internal, Jovo has an internal plugin for basic logging, and it's registered to listen to the request.start middleware. And so when that happens, it logs the request to the console. This basic logging plugin also responds or listens to the response.end. And at that point, it logs the response JSON out to the console. Now, in order to maintain user information across multiple sessions so that you don't lose information about a user, then there's a concept of a database plugin. One example of that is the DynamoDB plugin, and it listens for request.end. At that point, it uses the user ID that was passed and loads the user data from, in this case, DynamoDB. That DB plugin also has a response.end, and at that point, it saves any changes to that user data back to the database. And inside of the handler logic would be a place where you could either read the user data or add additional user data to be stored. And then it just automatically gets stored behind the scenes for you because you've got this plugin. If you wanted to affect ASR or NLU, you could do something like plugging in the Lex SLU or the Snips NLU. I added in this keyword NLU plugin. It's a way of kind of doing some hard-coded NLU. You've got a certain text phrase, and you can associate that with a specific intent. And this is showing an example of using that before or after handlers. So before any interpretation.nlu plugins or middleware is called, then this one's going to be called, and you could then, in essence, short circuit and map. If a very specific situation or phrase happened, then you could specify what the NLU was, what the intent was, and it could skip the NLU step because it already knows what the intent is. You'll also notice that there are these three internal plugins for router, the handler itself, and the output. And this is just showing that a lot of the main functionality inside of Jovo are plugins. So when the pipeline hits the dialog.router step, then it uses the information that it has as far as the context of where it is in the conversation, what the current intent is, and determines what the code is to execute. And then at this point in time, it takes that information and actually calls the handler, which is what's going to call our custom component handler code. And then the same thing with output. And then this is an example of a text-to-speech plugin. But what I wanted to show here is that there is a strong correlation between the pipeline and the different middlewares and the plugins, and that plugins are very important to Jovo. So really, the places that you can customize an application are based on what platforms you select, which plugins you include, and any custom code you write in the component handlers. So just a summary of what we talked about today. We looked at an approach of building a bot service from scratch. What would some of the functionality need to be in it? And we just kind of evolved that to a point where we could explore and see what was the primary functionality that Jovo gives you. And you could see that, yeah, we could write some of this stuff ourselves, but the fact that the Jovo framework has it already included in, it's not that hard of a concept, difficult to understand, but it gives us a good framework to build multiple different types of applications following the Jovo framework. We were able to look at what are the types of applications that we can build with Jovo, why we might want to use Jovo. We covered the concepts of platforms, pipelines, and plugins, and how those relate that the customization in our apps can happen by the platforms and plugins that we select, and we can write custom platforms and plugins if we want, and also the code that we add to component handlers. So I hope you've enjoyed this first video for Jovo 4 Explained as we talked about and introduced Jovo. I look forward to your feedback. Encourage you to share this video with others so that they can learn as well. And we'll explore more topics in the future in Jovo 4 Explained. Thank you.